Welcome to the Salt Lake City.net user group meetup. It's been a few months since we've done this, a number of months. And we have a website, slcnet.tech. It's good for linking to our meetup page. And there's some other stuff on there. So I actually didn't talk about this to the other board members, but here's the agenda I came up with. Welcome, which we're doing now. And then after that, we'll meet our 2 new board members. And then a presentation by Rob Richardson about .NET testing best practices. And when that ends, give away some prizes. And heads up, new board members, gonna ask you to just maybe tell a little bit about yourself. Starting, not yet, but soon. Housekeeping, we have a YouTube channel. There's this bit.ly link, slcnet-yt, or you can search for slc.net user group. I should have updated this. We don't have this streaming to YouTube, so won't be able to ask any questions there, but we will post it to YouTube after the fact. If you're hiring or looking for a job, I'd say post details to the chat. All right, Rob Richardson, a new board member. Tell us more about yourself, Rob.
I am a software developer. I work for a local global nonprofit. I also do a whole lot of conference speaking. I'm a Docker captain, Microsoft MVP, and MCT, a friend of Redgate, a Cyprus ambassador. And I think those are all the things. And I get to teach today, which is really fun. I've written a few, I've worked on a few books, so I'll get to show you those when the time comes too.
Nice.
Thanks for having me.
Yeah, glad to have you here. Thanks, Rob. And Frank V, tell us more about yourself.
Yeah, so I moved to Utah in 2019. Currently, I'm a engineering manager on a mostly front-end focused team, but I still, love .NET. I love Azure, and then outside of work, really enjoy hiking, skiing, and then struggling with my golf and racing game.
Nice. Thanks, Frank. Happy to have you. And now we're going to go to our speaker. He already kind of gave an about him. Anything else? He has some talks on his website, robrich.org/presentations. And you can follow him on Mastodon. He also works with Node React View. And I think most of the other stuff was covered. With that, we will now let Rob go ahead and present.
This is awesome. I will share the screen. There's the screen. Yeah, we get to talk about .NET testing best practices today. Here's the part. We're going to do a whole lot of live coding today, looking at IoT solution and building up tests for that. So here's the part where I tell you, I am definitely going to post the slides on my site tonight. But in this talk, there are no slides. But the code that we're going to work with today is already online. Let's go there. Here's this GitHub repo, github.com/robrich/nettesting xUnit MOQ. I'll put that in chat. And what I like about this is it has a start folder. Here's where we'll begin. Well, for the most part. And then here's where we'll end in the done folder. And so you can clone this repository and get from where we begin to where we finish, including we have a GitHub workflow here too. GitHub Actions workflow. So if that URL is a little bit too long, head to robrich.org, robrich.org, hit presentations, and here's .NET testing best practices, and you'll be able to get at the code right away. You can also find me tomorrow at Utah.js or in Mainz, Germany next week, where I'm teaching some other things too. But here's .NET testing best practices. The code is online right now. I've already done a little bit of an intro, but here's that slide that shows all the things. I got to work on SQL Source Control Basics and Pro Microservices in .NET 6. Still really applicable. It's an architecture book more so than a .NET 6 book, but its implementation is in .NET, which is really cool. One of the things I'm particularly proud of is AZ Give Camp. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver that completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp, or if you'd like a Give Camp here in Salt Lake, find me on any of the socials or here at the group, and let's get a Give Camp in your neighborhood too. Another thing I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air. They sent me a mug. Woo! So there's my claim to fame. You know, all of these other things are cool and all, but I've got a .NET Rocks mug. And if you'd like a .NET Rock, no, I'm just kidding. So let's talk about .NET testing. I pulled up this app here in Visual Studio, and it is a part of a fictitious IoT solution. And so we have this thing that allows us to turn on and off a light. We have this motion sensor that tells us if we've got motion. And we've got this light actuator. Now this light actuator has this actuate light function that tells us whether we should turn the lights on or off. Now these are not stateful lights, so we may turn on a light that is already on or turn off a light that's already off. But our task today is to test this actuate lights function. And so it does a whole lot of things of if there's motion detected, then let's update the last motion time. And then let's get the time period. If it's dark then and motion detected, let's turn it on. If it's light or it's been longer than a minute since we detected motion, then let's turn it off. And so that's the function that we want to test. Now we do have an implementation of this code just so that we can see it go. Here's our light controller, and we just have it kick off every second and flip whether it was actuated with whether the motion was sensed or not. We have a light switcher instance that will just write out the contents to the console. And so we can just have this detect motion and just flip it back on and off and on and off. So, you know, every second it will go do that. But that helps us understand what we need to do to kind of get this app running. Cool. So we won't run it. Our task instead is to create the testing function. So our first step is to create a new project. We can come in here and we can say add new project. We're in C# today, so we can limit this to Teams loves to consume my machine. We can say, let's limit it to C#, let's limit it to testing. And when we do that, we get the .NET test projects. Here's MS Test, NUnit, NUnit for .NET Framework, xUnit. I'm going to choose xUnit today because that is the framework that ASP.NET uses to test ASP.NET. That's a good enough recommendation for me. We can create that project and then talk about the framework. I'm going to hit cancel because I've already created that project. It is here a .NET 8 project, and we've got our content in place. So let's create our first test. I'm going to say add new item, and let's call this hello world. Here's our hello world test, and file scope namespaces for the win. Public class hello world, public void hello test. Each test in .NET is going to be a function inside of a class annotated with test. Well, in MS Test and NUnit, it's called test. In xUnit, it's fact. Fact. Why is it fact? Because they said so. Actually, the people who built NUnit said we've kind of pushed NUnit as far as we can go. We need to start over. And so they created xUnit. So now let's say assert dot that assert dot true, and we've got our test. Assert dot equal, and we can say, what do I want this to be? Let's say expected and actual. So we can say bool expected is true and bool actual is true. And now that will be as we expect. So how do we run these tests? Well, let's come here into the test menu and open up the test explorer. I happen to have the test explorer open down here, and it will now discover all of the tests in our project. We can push the run all button and it will go run all of those tests. And there is here a button that allows us to be able to run tests after build. And so that can be really helpful if you want to say, every time I build, I want to rerun my test to make sure that they still pass. Now, there is a thing in Visual Studio called live unit testing. That is not this. This is just a mechanism that we can use to be able to rerun our tests really fast. So it's first doing a build. That build succeeded. And now that we've got that, then we run all our tests and we seal our tests are green. We have one test. Well, let's change this to int expected equals 7, bool int actual equals 5. And now if we rerun that test, it's going to rebuild and then rerun the tests. And we'll see that that works just fine. Well, kind of. We've got a failing test now. Now, I spent a really long time debugging a test because it said expected 5 got 7. And I was like, okay, so it is expected 5. So I debugged the test and I got 5 as well. And I'm like, well, it expected 5. I got 5. Why is it failing? Well, actually, I had expected and actual backwards. So it's actually actual comma expected, or wait, is it actual comma expected or is it expected comma actual? I don't know. Let's introduce a new package. I'm going to come in here and I'm going to say manage NuGet packages, and I'm going to add xUnit. I'm going to add fluent assertions. Well, it's actually already installed. Perfect. With fluent assertions installed, we can do this a little bit better. We can say actual.should.be expected. Excellent. Now I don't have to worry about which way is it. Should it be this way? Should it be that? This kind of reads like a sentence too. Actual.should.be. And the cool thing is should is an extension method. So if actual is null, we don't get a null reference exception. Rather, we get a test that validates that it's null. Excellent. So let's make this pass. Oh, first let's take a look at the test results where it tells us 1 failed. And we can see what line it failed on and, expected 7, actual 5. It'll give us a stack trace. If we run this test again, we can see that now that we have fluent assertions, we'll get a little bit better error message. It will tell us more sentence structure, what we've got. So expected actual to be 7, but found 5. That's a whole lot easier to do. We've also got that same stack trace that'll get us exactly back to the line that failed. So let's make this test pass, and we've got that. Cool. So let's take a look at the code that we want to test, and let's enumerate the types of tests that we want. Okay, so we're looking at actuate lights. If motion was detected, we want to be able to see if last motion time got set. Let's create a new class here. I'm going to say add new item, and I'll call this light actuator, actuate lights tests. Now I've named it this way on purpose because file scope namespaces for the win. Here is the class that we're testing. Here is the method that we're testing. And now it's really obvious what these tests relate to. Perfect. So let's take a look at our thing and what tests we want. Well, we want a test that says motion detected, set last motion time, motion not detected, don't change last motion time. Excellent. We've got those two tests that we want to build. What other tests do we want to build? Well, let's take a look at this. Okay, so get time period. Do we want to test given a time, we get a certain time period? We could, but that's really testing this method over here. Let's set that one aside. Okay, so motion detected and dark, turn it on. Okay. Motion detected and dark, turn on light. And so let's do the opposite as well. Motion not detected and light. Motion not detected and dark, don't turn on light. Motion detected and light, don't turn on light. Excellent. Next up, we've got this one. Motion not detected, because otherwise we would land up here. And dark. Motion detected, motion not detected. Motion detected recently and dark. Don't turn off light. Motion detected recently and light. Turn off light. Motion not detected recently. Turn off light. Okay. So we've got some scenarios that we want to test now. And the cool thing here is we kind of looked at our code and thought through the various scenarios that we wanted to test here. We aren't looking for code coverage per se, but rather we're looking for scenario coverage. Have we kind of identified all of the paths through our code base? Okay, now that we've got those use cases, let's start building them into tests. Motion detected, set last motion time. Public void motion detected, set last motion time. Or I'm even going to say motion detected, last motion time changed. Now, it would be really easy to leave this empty or to move on, but it's really easy to now have an accidentally passing test. There's no assertions that failed here, so did it pass? Let's specifically throw a new not implemented exception so that we are very clear that the purpose of this test is to do what we want, and we haven't done that yet. Let's create another one. Motion not detected, last motion time unchanged. Excellent. So now let's start to implement these two tests. Well, I need to mark them as fact. Excellent. I actually end up with a meta test that will go reflect on all my classes in this test project. For every public class, for every public method, does it have a fact attribute? If it doesn't, then I fail that test because, that's another use case where it's like, hey, I think that's running a test, and it actually doesn't. So we want to do this. Let's take a look at the arrange act assert pattern. GitHub Copilot knows where I'm going. Arrange act assert. Now, we aren't doing test-driven development here, but let's test drive this test. Yes, if we were doing test-driven development, we would actually write the test first and then write the code that implements that. But in this case, we're dealing with this legacy system where the code was already written. Okay, so I've got this code and I want a light actuator. So let's say light actuator equals new light actuator, and then light actuator.actuate lights, and we'll pass in motion detected. Then I want to say date time last motion time equals light actuator.last motion time, and I will assert that last motion time dot should dot not be default. motion time, or I'll say instead of default, start motion time. Okay, so we did the act that helped us identify a few of the parameters that we need. We did the assert that helped us identify a few more. So now we only need to arrange the scenario that will get us there. Bool motion detected is true. Now we could just pass in true here, but that's not very descriptive. Why is it true? What is it doing? Is that important? Well, really, it's one of the main things in our system. So let's highlight that straight away in our arrange section. Next, we want to say date time start motion time is new date time 2011, and we'll give it a comment of why we chose that date, not recent. We just want something where it's obvious when it changes. If we said datetime.now and we ran this test quick enough, maybe it changed, maybe it didn't, we wouldn't know. And then the actual, let's change this to actual last motion time. That will come out of the system. Okay, oh, hey, last motion time. We don't have last motion time, and we actually need to set light actuator.last motion time to start motion time. But if we take a look at our application, this is a private field. Now we are using dependency injection, which is great. We have this interface that gives us this method, but we need this to be public to be testable. So let's make this public. And of course, somebody coming behind us, maybe us, is going to notice that it's not in the interface, and we're going to go add that into the interface. We don't want that. So let's very specifically add a comment that says public to be testable, not part of interface. Our application code out here should not be starting to set this. We don't want to say light actuator dot last motion time equals anything. That's not what this is about. We don't want that on the interface. We only want it to work in our tests. Okay, so now that it's public, we can write tests against it and everything will work great. Yes, we did have to change our production code to be able to test it. In this case, I think that was a good solution. The other way to go is to make this protected and inherit from it, or to make it private and then talk about friends visible to in the assembly. That gets kind of involved. I find this comment to usually be sufficient in why I've chosen to make this public, in spite of the fact that it shouldn't be used. Great, we've got a test. Let's run our test. I'm going to just run this one, run test. It'll pop open our build. And once our build succeeds, then it'll flip over and run our test. Build succeeded, test explorer. Oh, our hello test failed. Light switcher not initialized. I want to step aside from that for a minute and let's just copy this into place here. And in this case, it should be the same as, so it's unchanged, and motion detected is false. Okay, so let's run this test, run test, and we'll see that this test passed. So what is it about that uninitialized thing that we were looking at? Oh, light switcher not initialized. What is this light switcher thing? Let's go to here, light switcher not initialized. Oh, we created this singleton pattern here where we have this single instance of a light switcher. And yeah, our test didn't set it. Well, how would we clear that between tests? Yeah, this light switcher static instance thing is kind of annoying. Let's take this interface outside the middle of that class. That's good. And then let's just get rid of this whole instance thing. That's not very helpful. Instead, we want to inject an instance of that light switcher. So let's do this. We're using default constructors here. Light switcher. And now that we've got that injected dependency, we can come in here and create that light switcher, and we don't need that instance anymore. And now our code uses dependency injection to be able to get at that light switcher in our light actuator. Now in our regular code, we had this init thing. So let's say light switcher equals new light switcher. So we've done that. And then we need to, is our light switcher instance? Oh, haha, yeah, it needs to not inherit from that. Now we need to pass that in here, light switcher. Okay, there's our production code and it's ready to go. We did need to modify it slightly, but using dependency injection here is a really valuable way to make this code more testable. Now here in our tests, we should be able to build and run these, except for now we notice that we need to build this light switcher parameter here. Now we have that iLight switcher interface, so we could say public class mock light switcher, inherit that from iLight switcher, and go gadget, go make me the interface. Let's just say console.log right line, setting lights to off, setting lights to on. Thank you, GitHub Copilot. And that worked out pretty well. That's kind of a long way to go, though. Do we need to really make one of these classes for each one of the things? Let's reach for a library. Now, we could definitely use and substitute, but I'm going to use MOQ, mock-u, which allows us to be able to create a fake that thing. Okay, so let's do that. Let's create a fake iLight switcher. I'm going to delete this class right here. And let's say, go create a new iLight switcher. And then I can take that and I can pass that in. Object is that implementation of that one. And now I've got that light switcher that allows me to be able to do the things. Now, I don't really need anything in this light switcher. I just need it to exist. So that's perfect. Now let's rerun our tests and see if we've got passing tests in these two cases. It was great to be able to mock out that dependency so that we didn't have to worry about it, because the focus of our test was right here in this code, but it fell through. When motion detected, it went to try and go turn on the light and it couldn't. So we were able to mock out that dependency by just using MOQ to be able to fake that thing so that we could do that. Now there is a difference between mocks, fakes, and stubs, and that's beyond the scope of today. For today, I'll use those terms interchangeably, but yes, they are different. Cool. So we've got now 2 passing tests. We know that when motion is detected, we change the last motion time. And when motion is not detected, we don't change the last motion time. And the added benefit is we will always know that. Okay, next let's build a motion detected and light. Public void motion detected and dark, turn on light. Now we'll put the fact on there. Now I'm looking at this and I'm like, well, I'm going to need to write one for evening, one for night, one for morning, one for afternoon. I'm going to need to write 4 tests that are pretty much the same. Let's take a step back and say, well, could we write one test that took in parameters? Well, we could build 4 of these fact things, or we could say, let's say inline data, I want to say night should turn on the light and evening should turn on the light and morning should not turn on the light. And our last time period here, afternoon, should also not turn on the light. Cool. This actually turns from fact to theory when we have the inline data, but now we can say time of day, string time of day, and bool expected turn on light. Cool. Now we've done, oh, hey, we've done both of these tests and in all of their incarnations there. Excellent. So let's start setting this in place. We need to set up that. Now, part of this test is that motion is detected. So let's say motion is detected, true. Our start motion time, just not recent, that's fine. And then we need to be able to set our, actually, I think in this case, last start motion time is not relevant, but we can say actual turn on light should be expected turn on light. And now we need to be able to say, let's inject this time period. Now it's given a time, and so, well, time is based on date time now. Oh, so do we need to mock out this dependency? Well, we could, but really all we want is the results of this get time period method. Let's mock out this get time period method instead. Now, this get time period method is a private method inside this class. If we could separate this method into a separate class, then we could inject it into our code. So let's do that. Let's say public class time period helper. That's a really awful name, but we get it. And public interface time period helper. And what does that do? GitHub Copilot definitely knows where we're going here. Time period helper. And we'll make this public. Now, the cool thing about this time period helper is it's only a detail, an implementation detail between this light actuator and the time period helper. So let's just inject another time period helper in here. And now we'll use our time period helper to get at the current time. Excellent. Now we have modified our production code, so we need to now come back here into program and inject our dependencies. We need a light switcher and we need a time period helper. This writing all of the parameter, we didn't change anything. Can we just use dependency injection for this? Now, the cool part is if we create a new project, even a console project in .NET 8 or better, it will automatically build us a template that includes dependency injection baked in. Now, we built this in maybe .NET 6 or earlier, and so we don't have that. So let's see how we might add dependency injection to an existing project. There's this article that walks us through exactly that, where we can build up this mechanism where we're doing exactly what we did previously. We need to include Microsoft Extensions dependency injection. So let's come here to the NuGet packages and we will add the Microsoft.extensions dependency injection. And then with that added, we can now create a service collection and use our service collection to build an application. Let's do that. So let's come in here and we will say var builder equals Nope. Var services equals new service collection. And then we'll do services.add things. Let's add the content here. Let's also add services.add singleton. Time period helper for time period helper. And the cool part is because we define these as singletons, it will only get instantiated once ever. Perfect. So now we can say var IOC equals services.build service provider. And then let's go reach into our IOC, our DI container, and go get that one thing that we need. And it will then figure out all of the dependencies that it needs to go grab. We in ASP.NET, this is called app, and that's totally fine. In this case, it's a console app, so I'll just call it IOC, our IOC container. Cool. Now that we built, see, we don't have to worry about all the things other than just registering our new pieces. And now our production application builds again. Excellent. Well, if we come back into our tests, now we have to run through all our tests and update those as well. Is there a mechanism that we can use for dependency injection inside of our tests? You know, in this case, I don't even care what light switcher is doing or time period helper is doing. I need to satisfy the interface. Well, the cool part is we can use AutoMocker as a dependency injection container for our tests. Like the dependency injection that we do inside of ASP.NET or inside console apps, we can create this IOC container that just knows how to build up things. So let's do that. Let's come in here and let's say var IOC equals new AutoMocker. Let's move this into our global usings. Global using moq.automock. Oh, by the way, I added that to my NuGet packages as well. And now that we've got AutoMocker in place, instead of newing a light actuator, we can say, hey, AutoMocker, can you go build me one, please? Create instance of a light actuator and go fill in whatever dependencies you need. Now, the beauty here is if we've defined any mocks with this AutoMocker, it will use those mocks. And if we haven't, it will just make them up. Perfect. Now we don't need to worry about any of the dependencies that we don't need. Let's do that here as well. And so now we've got those tests already built and passing, and we won't need to futz with them again if ever we change the dependencies. Any questions or thoughts or concerns so far? It looks like duplicate lines on 61 and 63. Light actuator, time period helper. Oh, yes, you're right. Thank you. Let's put the correct dependencies in here. There we go. Good catch, Dwayne. So back at the farm, we want to inject the time of day. So we want to build up a time period helper. Let's say get a time period helper. Go get that mock. And then just like we do anywhere else, let's say, let's configure this mock. Now the cool thing, actually, I'm gonna GitHub Copilot helped a little bit too much. Let's set this up. We have a mock, And let's say m dot get time period. And when we do that, we want to say it returns the time of day that we asked for. Cool. Now we're calling this method, and it needs to pass in a string, a time period. And so we don't know what that string is. Well, we could say, or it passes in a particular date. Do we know what date that is? We don't. Let's say it dot is any date time. Cool. Now that it is any is kind of magic, where it just says, go figure out what the parameters are and just make them acceptable here. That's great. So now when you call this time period helper, it will automatically go inject whatever time we passed in here. Perfect. Now we do want to grab this as well to be able to know if this light switcher got turned on or off. Now this light switcher is injected in, so let's go set up a light switcher. Let's say var light switcher equals ioc.get mock I light switcher. And we're going to wire up this light switcher a little bit differently. Set up m such that m.turn on. And we don't need to return anything because it does the thing, but let's call our callback. And so we're going to have some callback that just does something. And in this one, we'll set this one to say actual turn on light equals true. Okay. Let's say bool actual turn on light is false. And now we've got that rigged up. Cool. So let's step through this test because we built up enough mocks that that's a little bit weird. I'm going to set a breakpoint right here and let's debug our test. Now, in the same way that we ran a test, let's debug a test and walk through it. Now, this is really cool. I love that we can just step into our tests and get a feel for how they work. So we've got a light actuator now. It's got all of its dependencies rigged up the way it needs to be. And let's F11 to step into this. F10 was motion detected. Yep, we passed in motion detected as true. So we set our last motion time. Then we go ask our time period helper for this. I'm going to F10 to step over, and we get our time period that got injected in. So there's that time of day that got injected into place. Now we're going to say turn off. Okay, so, there's nothing hooked up to turn off, and that's totally fine. Let's debug this again. What time of day did we get here? Oh, we got night. That's going to be really fun. So now as we step into night, was motion detected? Yes, it was. Is it evening or night? It is. And so let's turn on the light. I'm going to F11 to turn on, and we'll step into our mock. Now that's perfect. Now we have actual turn on light that is set to true. And so now as we leave our method and come back into our test, actual turn on light is true. And we can say actual turn on light dot should dot be expected turn on light, and everything works just fine. I'm actually going to delete this actual last motion time. We don't need that for this test. Excellent. So let's run all of these tests now and validate that they all run true. Now that was really cool. We built one test, one parameterized test that allowed us to be able to flex all 4 of these time scenarios. And because we were able to mock out those dependencies, we now have all of those dependencies in place in one test. That was really cool. Any questions or thoughts or concerns on this test? Oh, it looks like my face is stripy. Hopefully now my face is a little bit less stripy. Cool. So motion detected and light don't turn on light. We actually tested that right here in this test as well. Motion not detected and dark. Let's do a similar thing about these motion detected recently and not turned on. So I'm going to take this test because a lot of what we're going to do is really similar. Now, in this case, motion not detected recently and dark, turn off lights. No, motion detected recently. Let me double check this. Nope, motion not detected recently. Motion not detected recently would turn it off, but daytime would also turn it off. So let's say motion detected recently and light, turn off lights. There we go. So motion detected is true. That will get us, no, motion not detected. Motion not detected. That will avoid us getting into this spot. It will make sure we get in here. We need last motion time to be greater than a minute. So let's say date time start last motion time is new date 2001 and the important part here is more than a minute ago. No, that would actually get us into this one. We need to be less than a minute ago. So let's say date time dot now dot add seconds -3. Less than a minute ago. Now that does mean that we need to set last motion time there, but motion detected is false, so we won't change it. Now we don't want to rig up the turn on, we want to rig up the turn off, and this is actual turn off and expected turn off and turn off, turn off. There we go. Now in the night, we want it to turn off. At night, we don't want it to turn off. In the evening, we don't want it to turn off. In the morning, we do want it to turn off. In the afternoon, we do want it to turn off. And so let's take this test out for a spin. What do you think? Did we get it? I'm going to run all of our tests. Ooh, we've got one failing test. What is that test? Well, in this case, we have afternoon that's doing bad things. And when is it doing bad things? We expected it to turn off the light, and it did not. So let's set a breakpoint right here, and let's debug this test. Now, as we debug this test, it's going to do all 4 of these time periods. So I'm not sure if we got the right time period. Afternoon. Oh, we did. Excellent. So let's step into it. F11, step through F10. What time period did we get? Afternoon. Motion was not detected, so we didn't land here. Last motion time is within a minute. So, oh, if time period is morning or time period is, oh, we found a bug. It is not afternoon, but rather noon. This was good. We got to use our test to validate not only that our application is behaving as we expected, but we got to use it to help us discover some bugs in our application too. Now, yes, it would be easy for us to say after noon and then our test would pass. But let's go a little bit different and say, well, what is the bug that caused this? Is it that typo? I would argue no. Yep, now we've got 11 passing tests. I would argue no, the bug here is that we're using magic strings. So how can we solve that? Well, really, this is an enumeration, night, morning, afternoon, evening. Let's define that enumeration. Public time period, public enum, time period, and let's say night, morning, afternoon, and evening. Now, this time period is what will return from this method. So let's return that here. Let's return time period dot night and time period dot morning, time period dot afternoon, time period dot evening. And since the only part about time period helper is this implementation right here, we can just go grab that time period here and swap that into place with each of the time periods here. Excellent. So let's set this to time period dot morning and time period dot noon, which makes us have a compile time fail instead of a runtime fail, where we can actually set this to afternoon. Perfect. Our production application now builds correctly. We only needed to change that interface between those two classes, but we do have some failing tests here because, well, we were referencing this time of day that we now need to pass in the time period enumeration. Easy enough. Let's do time period dot night, time period dot evening. In a second, GitHub Copilot is going to notice and go, hey, do you want me to change the next one? Or I will have solved it by then. Time period dot night, time period dot evening, time period dot morning, time period dot afternoon. And with that change, we now have a runtime. We now have passing tests, and we were able to discover that bug. That is excellent. We can use our tests to be able to prove that our application works as expected, but we can also use our tests to be able to discover those sharp edges, those edge cases, and be able to discover the bugs within our application too. Now we've got 11 passing tests. For the sake of time, I will let the reader implement these two tests, and that will fill out our test suite, and we'll have great scenario coverage. Next, let's talk about creating an automated build. Now, I'm going to use GitHub Actions for this. So let's come in here and let's say Actions. I want to create a new build, new workflow. And now we can choose between a lot of different types of workflows. In this case, maybe I have a .NET app, but I could choose to deploy to various places, build in various ways, or I could create a simple app here that will get us started in a pretty good blank workflow. Now, this is just a file in our repository, .github/workflows. And so I can say build.yaml and then identify the steps that I want to do. Well, in this case, where is it going to run? I want it to trigger on the main branch and on pull request to the main branch. And workflow dispatch is actually really cool in that it allows us to have a build button. We no longer need to commit random stuff. And then it's just a set of steps where we can say, oh, this runs on Linux. That's perfect. It will start out by checking out our source code, and then we can run various steps. So in this case, we probably want to run things like this. Build and test app. I want to say .NET build. I'll build in release mode, and then .NET test. I will test in release mode as well. And now we'll be able to harvest our test results. We'll be able to run our tests. Well, how then might we harvest our test results? Right now, it's just going to do like we would here, where we could say .NET test, and it will run the tests and output a console that is perfect, but it won't then be able to show in a dashboard. As those tests run, let's take a look at how we might grab our test results. We can include the JUnit test logger package that allows us to be able to pass into .NET Test the JUnit format and the result path that we want to do. So let's come back here and let's add the JUnit package to our NuGet packages. And then we can say here, oh, it's still compiling. .NET Test, and we'll say logger, and we could collect XPlat code coverage. Let's do that. And so it's going to put these test results into test result.xml. Now, why would we choose JUnit instead of, say, xUnit or NUnit format? JUnit is a pretty universal format, and most CI dashboards are able to read it. So if we output in JUnit format, then we don't need to worry about moving our tests into a particular result format. So now back in our build, now that we've got that content set up, we can say, let's test, and let's say logger is JUnit, and the log output log file path will get us where we want our things to be. I'm actually going to back it up one folder so that we can get it out into the results. How might we then publish this into our dashboard? Well, we can use a test reporter here to be able to do that. This test reporter allows us to be able to publish things into a dashboard in a really pretty way. So, thank you for taking me to that picture. Yeah, that's a gorgeous way to do that. So how do we use this test reporter? Well, after we output our tests into whatever format we have, we can grab those here into place. So let's switch over to the done version of this build, and we can see that we did exactly that. So we ran that thing, put our results in this results/test results spot. And so let's go find those results/test results, and we will use our JUnit reporter. And it's important that we very specifically do this always. If we don't do it always, if we have failing tests, we won't get the test results, which might defeat the purpose. So let's come in here and let's build our app. I'm really glad that we have this run workflow button here that will allow us to build it. And now that we've got that running, there's our new one. We can see how that build goes. It's going to do each of those steps: .NET build, .NET test, harvest the test results, and save them in an interesting way. There we go. And the interesting thing that I found here is that it actually doesn't put the test results on the build that it just did, but rather the first build of this commit. So here's our test results. That's actually a bug in GitHub. But here's our test results that ran just now. And so we saw that all of our tests succeeded. And here's the execution time for those tests. So that was really fun getting to walk you through .NET testing best practices. We started with the start and we ended with the done. And so you can clone this repository here on robrich.org and be able to replicate these results. This was really fun. Thanks for coming to .NET testing best practices.
Thanks, Rob.